Let's take a look on this problem. In this problem, we need to check for the wood beam. So first of all, we need to open the canvas, and you need to go to the formula reference over here. Let's open the formula reference, and then I want you to go all the way to the bottom until you see check wood beam. This is wood column. So now you have wood beam. Check wood beam right here, and then we just follow up the step similar to the step we did in the checking for the steel beam. So first of all, we need to calculate for the design bending stress, and to check for that, you need to look for the table 4A in the NDS or the AWC, this reference, American Wood Council reference. If you have lumber, then you check for table 4A, because for table 4A is lumber that you see that 2 to 4 inches thickness. If you have timber, then you need to check for table 4D. 4D is on the bottom over here, 4D. Because the question we have is we have lumber. This one is 4 by 2, that is a lumber. So we need to check for the table 4A, the table 4A. All right, so let 5FB. So first of all, step 1, we need to find FB. So the type of wood we have is Alaska yellow cedar and select structural. So let's go back here. We need to check for Alaska yellow cedar in table 4A, and the gray of that is select structural. So we need to check for FB. So FB of that will be 1350. 1350. So we have 1350 psi. And now step 2. Step 2 is to go to formula sheet here. Step 2 is to look for the design shear stress. Also check in the same table. So I have here is FV design shear stress will be 225. FV will be 225 psi. Now step 3. Step 3, we need to calculate for the air max, and step 4, we calculate for V max using the bending moment diagram and the shear diagram. So as you can see over here, we have this one is a simple beam. If I draw this one in a normal case we did for shear bending moment diagram, it will look like this. For this one, you can use software or you can use reference. Last lesson, I used the reference. So maybe in this lesson, maybe let's try to use software. But keep in mind that you can use any method. This one, you can even use the manual method. So we have here is 15 feet, 20 POF. Then go here, home, software. We have here is a length is 15 feet, and we have one pin on 0 and one roller at 15. With the distributed load is 20 and will be 20. 1 to 15. So we have here the air max will be, you can see over here the air max as they summarize over here will be 562, and the V max will be 115. So I can write here we have M max 562 pound feet pound foot, and this one is 150. So step 4 V max will be 150 pound. And because similar like we did in steel checking, because this one is PSI, which means pound over square inch, while this one is feet. So we need to convert this one to inches. So 562 pound multiplied by 1 foot equal to 12 inches. So I'm gonna have here 562 multiplied by 12. I have 67044. 6744 pound inch. And now let's check step 5. Alright, for step 5, we go back here and you can see that step 5 FB, we need to calculate the small FB, so which means we calculate the required value. Step 2 and step 3, you need to 1 and 2, you need to calculate for the desired value, and step number 5, you need to calculate for the required value. The required value will equal to M max divided by S. So let's use F B will equal to M max divided by S. So M max you have that is 6744 divided by S. S you have here. So now let's check for S of the of this beam, 4 by 2 or 2 by 4, just the same thing. So let's check for 2 by 4. 2 by 4 here. And over here we have 2S. We have S of X and S of Y. Which one we should use? So now you take a look here. So it's obviously that this one is placing in a way that is maximize the use of the material. So to maximize the use of the material, we should put the beam like this instead of like this. This one will be weaker, it's easier to bend, and this one will be stronger and this will be harder to bend, and this one will be the strong direction. So we're gonna use the larger S. So that means we need to use the S of 3.64 3.06 over here, 3.06. So we have 3.06, and that one will equal to 6744 divided by 3.06. We're gonna have 2204 psi. Next one is step 6. Step 6 is to calculate the required shear stress. So step 6. We have the FV equal to, now because this one is for wood, we're gonna use this formula, 3 V max divided by 2A. 3V max divided by 2A. 3 V max divided by 2A. 3V max divided by 2A. So you're gonna have here V max will equal to 150, and A, for A we need to go back to the reference here, and if you check the reference of 2 by 4, you can see that A of that will equal to 5.25. Multiply 5.25, and this one is square, this one is pound. Finally, we're gonna have 3 multiplied by 150 divided by 2 divided by 5.25. So we're gonna have 42.86 psi. Now step 7, similar to steel, is to check for bending, and step A is to check for shear. So maybe let me go to the next page. Step 7, check for bending. So we have design value will equal to the design value is FB here, equal to that, and the required value will equal to small fb multiplied by FOS. Small fb we have 2204 multiplied by the FOS in the problem here is 2.0. That will equal to 4408 psi. So yeah, as you can see, the design is smaller than required. So this one bending is not okay. Step 8, check for shear. Normally, if we check for bending, that is not okay. We don't have to check for shear. We just redesign that one. But I just want to complete the whole problem of the steps so you can see everything here. FV will equal to what we calculate previously is 225 psi, and require will equal to small fv multiplied by FOS equal to 4.86. Oh, sorry, 42.86. 42.86 multiplied for FOS, it will equal to 85. Oh, this one is 85.7 psi. So design is larger than required. So the shear is okay. Conclusion: the design is not okay.